When you think of the Cold War, you probably picture spies, nuclear submarines, and satellites racing across the night sky. But deep in the Arctic tundra, where no power grid reached and temperatures could freeze diesel into sludge, another kind of technological battle was unfolding. Scientists and soldiers needed power, steady, silent, and dependable power, to run weather stations, radar outposts, and secret listening posts. And since batteries died in the cold and fuel was unreliable, they turned to something truly radical: small nuclear power sources, devices that literally turned radioactive decay into electricity. These were not science fiction. They were real, rugged, and they changed how remote survival worked forever. Let's dig into how the Cold War's forgotten atomic batteries kept the lights on in the frozen north, and how understanding them today can inspire off-grid energy systems that don't rely on the grid, gas, or sunlight. During the Cold War, power meant survival. In the early 1950s, the United States, the Soviet Union, and even Canada began dotting the Arctic with weather stations and radar domes as part of the Distant Early Warning Line, a chain of installations meant to detect incoming bombers before they reached North America. The problem was the Arctic was a logistical nightmare. You couldn't rely on sunlight in winter, diesel froze, and generators were noisy and required endless resupply missions. This is where a radical idea emerged. What if power could be generated continuously without fuel, engines, or maintenance? The answer came from a technology originally developed for space: radioisotope thermoelectric generators, or RTGs. These compact devices converted the heat from decaying radioactive material into electricity using thermocouples. No moving parts, no fuel lines, no batteries to swap. While most people associate RTGs with spacecraft like Voyager or the Mars rovers, few realize they were also installed on Earth, quietly powering Arctic lighthouses, remote weather beacons, and navigation systems where nothing else could survive. At the core of these Cold War RTGs was a small pellet of radioisotope, often strontium-90 or plutonium-238, sealed inside thick shielding. As the material naturally decayed, it released heat. That heat was captured by thermoelectric materials, special metals that produce electricity when one side is hot and the other is cold. It's a simple principle, but in practice it was a triumph of engineering. In the Arctic, where temperatures could plunge below -50 degrees Celsius, the freezing air itself became the perfect cold sink. The greater the temperature difference between the isotope core and the outside environment, the more efficient the generator became. These units could run for decades without refueling, literally generating electricity from nothing more than the steady heartbeat of nuclear decay. To put it in perspective, a single RTG about the size of a car battery could power a small communications relay, a set of instruments, or an emergency shelter indefinitely. No need for maintenance crews, no fuel convoys, and no engine noise. One of the most remarkable deployments was along the Soviet coastline and across Siberia. The USSR installed hundreds of RTGs to power navigation beacons and meteorological stations. These units, called Beta-M or Gamma series generators, often sat unattended for decades. Some were forgotten after the fall of the Soviet Union, rediscovered years later by scavengers who didn't realize they were handling radioactive cores. In the West, the US also experimented with small nuclear power units for Arctic research bases and satellites. The most famous was the SNAP, or Systems for Nuclear Auxiliary Power program. These SNAP units powered early satellites, deep-sea sensors, and Arctic outposts where even aircraft resupply was dangerous. Each device was hermetically sealed, designed to withstand crashes, fires, and temperature extremes. Though many of these installations have since been decommissioned, they laid the groundwork for today's microenergy revolution. Understanding RTGs isn't just Cold War trivia, it's a lesson in resourceful, self-sustaining design. They remind us that real resilience comes from simplicity and reliability, not complexity. You don't need a reactor or plutonium to apply that principle today, but the mindset behind RTGs, self-contained, long-term, maintenance-free energy, can shape how we think about off-grid living and emergency preparedness. For instance, a modern homesteader or remote explorer could mimic the principle of heat-to-electricity conversion using thermoelectric generators, or TEGs. These are safe, compact devices that work on the same physics as RTGs, only using ordinary heat instead of radioactive material. A practical way to do this is by setting up a wood stove or biochar burner with thermoelectric modules on the sides. As the stove burns, the modules generate steady current that can charge batteries, power radios, or run LED lighting. Exactly what the Arctic outposts once did, minus the radiation. Another example. Field researchers in polar regions now use passive systems inspired by RTGs, where heat from composting or geothermal vents is converted to low-level electricity. The concept stays the same. Capture waste heat, turn it into usable power, and keep critical systems running even when the sun and fuel give out. Though the Cold War ended, RTGs never truly disappeared. They still power ocean buoys, deep space probes, and autonomous research stations where sunlight and fuel are luxuries. The lessons they taught about endurance, isolation, and human ingenuity continue to echo in survival engineering. In a world obsessed with batteries and solar panels, these forgotten devices remind us that energy independence doesn't have to mean fragility. It can mean systems that endure for decades without human touch, just as they did on the frozen frontier half a century ago. The next time you think of the Cold War, don't just picture missiles and maps. Think of those silent little generators humming under the snow, keeping the instruments alive through the longest winters humanity has ever endured. If you found this dive into forgotten Cold War technology fascinating, make sure to subscribe to In the Beginning for more deep, documentary-style explorations into the tools, materials, and survival tactics that shaped modern history. Share this video with a fellow history enthusiast or off-grid tinkerer, because the past doesn't just teach us what was possible, it shows us what still is.